Good morning, everybody. Friday morning, day 3. Have you seen as much as you wanted to see? More stuff to see today? Anybody going to the workshops tomorrow? Yeah, I'm going to go to both workshops tomorrow. That is, I haven't decided which one. At any rate, our keynote speaker today is Rich Mogull. Rich Mogull is kind of a demigod in my information security world. He's well known in the InfoSec world, but he's also a security editor for TidBITS magazine, so he's actually a big name in the Mac world too. So he has a foot in both worlds. So we're going to have Rich talk about information security in the Mac environment.
Thanks, Dan. And thanks, everybody. Oh, wow. Well, I mean, with a start like that, I think I should just leave before I screw it up. So I'd like to welcome everybody to the session. And it's kind of interesting covering Apple security. This is something that I've done. I started nearly 10 years ago. And to be completely honest, it wasn't really good back then. We were kind of living in a bit of a different world, and in terms of how Apple viewed things and the overall environment. And if I look at what Apple security is like today, it's significantly different. It's materially improved. And there's a lot to talk about. And I have 30 minutes, and that ain't going to happen. So there's no way to cover absolutely everything. So what we're going to do is I'm going to do a little bit of a setup here and talk about kind of some of the generic background about kind of how I think Apple thinks about things, which is probably as a Mac writer, it's pretty much the most dangerous thing you can ever do is to think you understand Apple and how they think about things. And then we're going to go ahead and I'll walk through OS X, iOS, and iCloud. Now, I don't know the technical level of everyone here in the room. Not exactly sure what you guys are looking for. So I'm going to try and keep this pretty interactive, get feedback from you. We can drive this in whatever direction you want, because I want to make sure you get the information you're looking for out of this session. But to start, I think I wanted to spend some time on Apple's security philosophy, because if you understand this, you will understand the vast majority of decisions Apple makes when implementing security in their products. And it's very different than other vendors out there. For example, Microsoft. And I'm not going to knock Microsoft, because Microsoft actually has, for those of us that cover enterprise security, one of the best security programs in the industry. They've done incredibly significant things to improve security on the Microsoft landscape. The problem is everybody's still using XP, like 98% of ATMs or something, which is going to be fun, because Windows XP goes out of security support this week or next week. So stop using ATMs for a while. I don't really know what the answer is to that one. But let's go back to Apple. And I won't lie, I mean, Apple used to kind of have their heads in the sand. Security wasn't an issue. It was all about usability. And to be honest, it was okay. It bothered me a little, but not too much, because Apple's really just weren't attacked back then. We didn't have the kinds of issues. And there was the whole market share argument. Whatever, throw all of that out the window these days, because we now know that Apple's products are pretty much the most popular ones on the face of the planet. They sell more laptops, they've got the highest margins, iPhones and iPads. I mean, the numbers are just staggering. And anybody who tells you that Mac users and Apple has their head in the sand I don't get that, because clearly these things are targets. And clearly we care as Mac users, as Apple users, about security. And so if I think about Apple's security philosophy, there's a couple of really important points. How many of you come from the enterprise at all? Businesses, you're dealing, like everybody, I figured MacIT. And you guys know that the way Apple views devices is that there's 2 categories of devices, and there's 2 categories of data. And this is a very deep, and they have talked about this in sessions at WWDC and such. There is employee-owned, and there's personal-owned. Or, I'm sorry, employer-owned equipment. And Apple is not going to sacrifice the user experience for employee-owned equipment, and they think that we, the owners of that equipment, that our data is ours, and that these devices are ours. We paid for them. We use them. And the enterprise shouldn't be able to degrade the user experience, and they shouldn't be able to get access to our data or information except where we give them permission to. And that design split goes across the product lines in everything they do, down to the point of where if you're an enterprise and you're part of the volume purchasing program, and you distribute licenses for software onto employee systems, there's actually a mechanism that they use so that when the employees put their Apple ID in the iTunes store to download the corporate version of Evernote, that the employer doesn't actually have any information about the employee, gets no access to their private information. So there's actually an intermediary service that they put in place so that we as the employees are protected from our employers being able to gain access to any of our personal information through any of Apple's ecosystem. It's really fascinating stuff, and it really defines a lot of a different approach, because if you look at primarily Microsoft, because they're the only other ones that make stuff that we use in work environments like that, or even someone like BlackBerry, where typically it's the employer owns and has access, and they take full control over things. And Apple focuses much more on how can we gracefully divide so you can use both devices. And how can we do that in a way that doesn't damage the user experience? Samsung Knox or these container programs or anything else that people have heard about, for the most part, that's all about creating an entirely different persona on the device. And that's not the way Apple thinks. They want people to use OS X and iOS, and most of this is very iOS specific, the way that they always would use it, whether they're at work, whether they're at home. So when you go into email, you're in the native Mail client. And so what they do, instead of giving you a whole new version of Mail and a whole split personality, they actually have it so that if it's a work account, if work wants to, they can set a policy where you can't move a message from a work email folder to a private email folder. Or that when you open a work attachment, you can only open that in applications approved by work and distributed by work onto your device. And so that split is just fascinating to me, and and I think it's going to take us in some very interesting directions, because no one ever thought of it before. They just saw, well, it's work. Work has to have full control over everything. Now, this does confuse a lot of your enterprise IT departments, and there's a lot of education that needs to go on, and a lot of explaining what the security risks are, and it's a whole different view, and that's going to take time. And we know, and there's holes in how these things work, and Apple's going to keep locking it down. And I'll get more into the specifics of iOS in a minute. So the other piece of this is that Apple puts intense effort into the security user experience. Now, I can tell you other companies I know do this. I've had conversations with people at Adobe, with people at Microsoft. I work at the high enterprise IT level, and I know that they spend time on this. But I'll be honest, they also spend time working on the user interface of like Windows Vista. And we all know how that worked out. And because of that, Apple's design sensibility shined through. And so a lot of detail is put into what window opens where, what are the defaults, how do we guide the users to making the right security decisions without having them become security experts. Who has set up a new iPhone or iPad in the past year? Yeah, really dumb question with this audience, probably. And how hard is it to set that up with no passcode? I mean, Apple's making it harder to not put a passcode on your device. And they deliberately say things, oh, well, you don't get Find My iPhone if you don't put a passcode on. Could they have enabled Find My iPhone without a passcode? Certainly they could have. But it's more incentives to drive the users towards making smart decisions. Gatekeeper. So we'll talk more about, a little bit more about how Gatekeeper works, but Gatekeeper on OS X, which is the mechanism, and we all probably have it turned on if you're on Mavericks, where when you go to download software from the internet, you can only launch things that either come from the Mac App Store, that's one setting, or from the Mac App Store and developers with a developer ID, so Apple can track those and potentially remove those if they're malicious apps, or anything. So not only do they set it at a very sensible setting, when you actually go to open something that would violate a gatekeeper policy, the steps you have to go through make it hard for the user to mess it up. I'll give you an example of that. When many operating systems and graphic user interfaces, if you go to do something that would violate security, you get the yes/no dialogues. Apple does some interesting things. First of all, when you get to the point where you even want to open something that could be risky, you'll notice that they flip the yes and the no, so that you can't instinctively click through. If you instinctively click through, what you will choose is the option that is more secure, based on our habits of always clicking, the left box versus the right box. The other piece of that is you have to right-click to even get the option to open the thing in a less secure way. Now, it confuses users who want to do more advanced stuff the first time, but for the average users, for my family members, I am very confident that when I turn that on, the odds of them making that wrong security decision are low because the user interface has been fundamentally designed to guide them towards the more secure settings. And Apple's not the first to think about this. Microsoft, with their Trustworthy Computing initiative, secure by design, secure by default, are the first two principles of trustworthy computing. It's just Apple's been doing a really good job with it, and they only have a few places where they have to implement that. And then the last thing in terms of philosophy, so it's you own your devices, you own your data, which also shows through an iCloud, as we'll get to. There's user experience matters, and the last one is kill the ecosystem. Apple's in a very lucky position. Microsoft's security, inherent security within their operating systems is tremendous. It really is some best-of-breed stuff. They will give you $100,000 if you find a way to bypass certain parts of their anti-exploitation technology, and you can demonstrate that to them. And people have done that, 100 grand cash. And they're making it as hard as possible to circumvent those controls. But the problem is it's still less safe on Windows because before they did this, Windows had such market share, and Windows is so highly attacked, there's an entire ecosystem of malware and attack techniques. Apple was able to avoid those problems. First on iOS, because applications were so locked down. They built in sandboxing from the start, some of the other technologies that we're going to be able to go ahead and talk about. And now with OS X, they're focused on making the malware criminal ecosystem not cost effective. So they're increasing the economic cost to attackers. Gatekeeper is one of the best examples. When Gatekeeper came out, I think I was quoted as saying, that just wiped out any possibility of persistent widespread malware on Macs. We'll get the occasional big infection. We'll get small infections. Believe me, this stuff's far from perfect. I got a lot of hacker friends. There's plenty of holes in iOS and in OS X that can be exploitable. But the bad guys can't make enough money. Like Gatekeeper. If Gatekeeper, by default, and the biggest way to get this malware onto people's desktops is through download, and it can stop a big chunk of that mechanism, which is what it's designed to do. Now all of a sudden it's harder to nail users with phishing attacks, it's harder to nail users with drive-by downloads, it's harder to nail users with all sorts of attacks. Another one, so there's a lot of problems with Java, and Java in web browsers, and it's not Apple's fault, it's not Microsoft's fault, it's Oracle's fault. It's pretty bad there. And because of the Java applet issue, and that's the most common way that we've seen exploits on OS X through the web browsers past couple of years. And by the way, it's also a huge issue in the Windows world. Apple said, okay, we're going to turn off Java in the browser. We're not even going to install it on the operating system. If you need it, it's just one click away. If you want to turn it back on in the browser, you can do that. And if you don't use it for 90 days, we shut it off again, which is how Safari works, so that it actually prevents and puts in these extra layers of control. And it's just all about increasing that economic attack because it's harder for users to hit a wide swath of the Mac-using public. And when they do that, it really disincentivizes them to target Windows when they can still go after all of our ATMs running Windows XP. So, any questions about that? So, this is the part of the talk where I'm going to kind of roll through, but I just want to get a gauge. Who is more interested in kind of the underlying technologies of how some of this stuff works? Who's more interested and wants to see me how I configure my systems? Okay, there's too many hands for both of those, and I don't have a lot of time. So we got 15 minutes left. Let's get rolling. So OS X, I talked about a lot of this already. OS X, it's reasonably secure. There used to be some pretty big holes in it. There's not those anymore. Like any operating system, though, general-purpose desktop operating systems are pretty much impossible to fully secure. So there's going to be vulnerabilities. There's going to be exploits. There will be malware, pretty much indefinitely. But as Mac users, because Apple's attacked that ecosystem and continues to attack that ecosystem, it's just we're not ever going to have those epic waves of ongoing malware all the time. Might have a big one here and a big one there every couple of years, but that'll probably be the extent of it unless something changes. Internally, there's a lot of inherent security controls. There's sandboxing is implemented at the operating system level, and it's something that's now implemented for all applications you download from the Mac App Store. So they're all sandboxed, they all have to get permissions. You know, developers complain a lot about that in some cases. But there's tremendous advantages to that, because when you download those apps, even if a bad guy exploits that app, it makes it harder for them to transition that exploitation to the rest of the operating system. It's not impossible, but it's harder. And when they do something like that and they find sandboxing breaks, jailbreaks, then Apple can go in and fix it, and it makes it that much harder for the next guys. So that's a combination of an inherent control and the security system. And by putting sandboxing in at that operating system level, not only can apps use it, but a lot of the native applications can opt into different forms of sandboxing. You can actually see this with, oh no, that's what I want. If you actually look at your applications, you can actually see what they're running at, and does it have it here? Where's the part? You used to actually be able to see if it was sandboxed or not. There's a way of doing that, so I apologize. I thought that would pop right up. That's what I get for trying to run something live on stage. All right, so let's get back. But you can actually tell, you can look at running applications and processes and see which ones are sandboxed. Now, the next thing is we use address space layout randomization and data execution protection. So what DEP is, it means that memory locations on the hardware can be designated so they can only execute code or they can only store information, and you can't do both. And that makes it harder for bad guys to do certain kinds of memory exploitation attacks, buffer overflows and stack overflows in particular, where you put a bunch of junk in and you overflow a command into part of the memory stack and then you can get it to execute. Well, this is implemented at a hardware level. It's something that Intel employs at most modern operating systems, including OS X and iOS and Windows, all use. And ASLR, which is address space layout randomization, which is core areas of the system memory, are randomized every time you reboot your Mac. And why does that matter? Because if the bad guy gets a very fundamental flaw in your system, it's to execute arbitrary code, he usually has to directly manipulate memory locations to hook in to be able to do something bad. And ASLR means that can be in one of 256 plus random locations. And so it makes it much, much harder for attackers to actually get their footholds on your operating system. And even better, Macs are all 64-bit operating systems these days. All the new hardware you get, there's actually a lot of additional security that's built into the Intel chips that OS X now takes advantage of. This is better than, to be honest, the Windows world, where if you buy that cheap 32-bit laptop, you don't get those extra enhancements because you're not running on the latest processors. But with OS X, we're always running on the latest generation of processors, and that always enhances our defensive capabilities, and the 64-bit systems in particular are much more resilient to attack. Now, the other things that you have are FileVault 2, Gatekeeper, and the firewall. Let me go ahead and I'll actually show you guys how I configure mine. FileVault 2 is full disk encryption. I highly, highly, highly recommend it. The old versions of FileVault used to just encrypt your user space on your particular system. But with OS X, it actually encrypts the entire operating system. And when you boot, you're not actually booting into your operating system. When you put that first password in, you boot into something called a pre-boot environment in the disk encryption world. And you have to authenticate in that pre-boot environment, and then that unlocks FileVault for you so you can get into your operating system. You have the option to store backup keys with Apple if you want, and there's actually a secure recovery mechanism. I don't do that because I don't forget my passwords. And it's very, very resilient. The old versions of FileVault, I've lost data. If you ever used it, I guarantee you probably lost data. Current version works great, works well with your backups, because full disk encryption implemented properly, and by the way, I think it's some old PGP guys that went to Apple to implement this, is actually extremely effective. And if you're worried about things like when you travel to China or you cross borders, some government snooping at your stuff, just make sure you turn your computer off, that you don't just close your lid, because shutting it down pulls all the keys and stuff out of memory, so they can't do like the in-depth, government level hacking stuff. Now, the other things that I configure on my system, strong password, obviously. I always require it immediately after the sleeper screensaver. And I have Gatekeeper from the Mac App Store and identified developers. Some of my family members, I have them just on Mac App Store, because if they want to download something randomly off the internet, they should be calling me before they do that. But and then I say, no, stop. But for general users, most of you guys, you want both. The other thing to remember about Gatekeeper is it doesn't help you if you plug in a USB drive. It's only for downloaded files. Okay, it uses a particular mechanism that actually tags files as they're downloaded. It also doesn't capture everything from every application that can download files. If you look deep in OS X, you'll see that there's a list of apps that are tracked with, what is it called, XProtect. And not everything is tracked. So if you have some obscure FTP client, you are free to download all the malware you want. Apple's not going to stop you. But all the core parts of it, they track those apps, and they're actually able to mark those files when they're downloaded. And then lastly, I turn the firewall on. There's two firewalls on OS X. One is the application level firewall, or makes smart application decisions based on your applications being code signed. It's an inbound firewall only. So I use a product called Little Snitch for outbound, if you want to get that as well. But the other option is that if you say block all incoming connections, that just doesn't matter, locks everything down. And you'll notice that that's the setting that I have on right now, because that's what I use when I travel and I connect to hotel networks and such. My home computer is more open, and that's a more protected network. But out here, travel, and I'm on the road pretty much every week talking about security stuff. And then the last part is the privacy. This is new in Maverick. Is it Mavericks? They started introducing some of it in Mount Lion, where you can actually control what parts of your system that apps can access. It's very similar to what's available on iOS. This is great. Location data, Twitter, your personal information. This makes it harder for apps to steal your stuff off your system. Remember, your data is yours. Apple wants to protect that data. This is something they ported over from iOS, which I think is great. So you don't turn it on or off. It's actually always on by default, and you have to manually go through. So you can see location services. I've allowed those, but I don't allow a lot of other stuff. Contacts, that's the things that can access my contacts. Don't ask me why PDF Pen wants access to my contacts. A lot of that is because they pull your individual personal information, your, like, who are you, and then they use that to things like if you have a writing application to fill in your name. That's why you get a lot of these prompts from weird apps. All right, any questions on OS X? I don't spend a lot more time on configuring my Mac. I add Little Snitch. I'll get to you in 1 second. I do Little Snitch, strong password, passcode immediately on these screens. I always turn on File Vault. I always turn on the firewall. Privacy you don't have to do anything with. And the only other part is within iCloud, if you use it, I will frequently turn off Find My Mac, because if somebody hacks my iCloud account, I don't want them to be able to remotely wipe my Mac. I'm debating on turning this one back on, to be honest. I might do that. Because remember, it's like Find My iPhone. You can locate it, but you can also remote wipe it. I'm confident enough in my encryption, my other security, that I don't feel the need to remote wipe my device if somebody gets it. Because the only people who can break through that are, you know, the NSA or China, maybe, and maybe not. And then back to my Mac, I do have that, but you'll see my firewall settings have it turned off. And I use that on my home computer to go back to it, although there's other screen sharing tools that I tend to prefer. And then don't forget to use Time Machine to back up. Your question. Yes. So you can have your firewall set so it won't respond to pings or anything else if you turn off all the sharing on OS X. It will also block any inbound connections. There's a lot of services that are running you may not know about that you can't directly control through sharing preferences. So if you run a tool like Nmap or you do against stock OS X, you'll actually find that there's some things that are open that you as a user you can't disable without going ahead and hitting that on the firewall. Yes, sir.
With Mavericks, they introduced Keychain in the iCloud for
We'll get to
storing it?
Keychain in the iCloud. I have a
Okay,
whole.
because I wanted your opinion on that especially.
Yeah, it's impressive, and I only can say that because they released documentation a few weeks ago on it. All right, so we're going to be pretty tight on time, so I'm going to have to roll through this stuff pretty quickly, and I'll show you how I configure. But for iOS, these are right now the most secure computing devices you can use. They are. Are there vulnerabilities on it? Yes, I know about exploitable ones that are out there. Doesn't matter. There's no widespread malware. The whole Mac App Store ecosystem in your app sandbox. And when you deploy an app, it only has access to its own stuff. To gain access to anything else, you, the user, have to approve it. That works pretty well. We've only seen a few breaks of that over history. It has all the inherent controls to avoid anti-exploitation. Why? It still actually runs OS X. We forget that iOS and OS X have the same base operating system. Flaws that appear in one frequently appear in both. Security benefits that appear in one will tend to appear in both. So that core, particularly at the kernel level, they're very, very, very similar in terms of what's going on. And I talked about the split and then you also have control over the privacy settings, which I'll go over. And then the other part is code signing. Everything on iOS is pretty much encrypted. There's cryptographic hardware that's built into our devices. And every application is code signed by Apple and by the developer who signed that particular application. And there's a whole code signing mechanism to make sure that those signatures are valid before that program can execute. Now, Android can have something similar, but it's not as effective. There's a lot more flaws in it. OS X, has just done a great job. And as much as people complain about the closed ecosystem, as a security expert, you can't secure open ecosystems. It's just not possible. And so this is so locked down in many ways. And again, I'm not complaining. I have no problem doing everything I want on iOS. But because of all of those lockdown capabilities, it actually makes it much harder for the bad guys to do anything on those devices. The other is that all the devices have hardware encryption. Everything's always encrypted when you set a passcode, particularly on your device. It's always encrypted, but if you set a passcode, that implements data protection. And that means every app sandbox is encrypted to your passcode. The base encryption on iOS is just for device wiping. So if you want to wipe the device, it wipes the key out of memory, and everything that's stored on the device is inaccessible. That doesn't protect you if somebody actually can log into your device, or that doesn't protect you from jailbreak attacks. If somebody can jailbreak the operating system, exploit that operating system, then they get access to all of your data. If you put on a passcode that enables data protection, each sandbox is encrypted to your passcode. They have to get your passcode to be able to break into that level of encryption. Now, also, that passcode has to be entered on the device, unless they pull off an iTunes backup or equivalent. That means that because what they do is they seed your passcode with a unique device identifier code, which is embedded in hardware and you can't pull off of the device. So if you pull the data off the device and you try and decrypt it someplace else, it won't work, because they don't have that hardware embedded number, that hardware embedded code that needs to be combined with your passcode to actually decrypt. Pretty cool. And so it's very strong. It's hard to break. Now, if you have a 4-character passcode, somebody can go on your device, they do an exploitation, they'll do a jailbreak, and they can break that usually within a day. If you use a longer passphrase, anything particularly 8 characters or longer, they cannot effectively crack your password and get access to your device. So that's why I set all of mine for at least 8 characters. I think mine are usually 12-character passphrases. And it's just a passphrase I remember. Now, what's the problem with that? Well, it's a real pain to enter with your thumbs on one of these. So everybody go buy an iPhone 5S, because then you can use your fingerprint with Touch ID. And Touch ID is interesting because it uses the Secure Enclave, which is dedicated hardware chip. I made some initial predictions. I thought they used an ARM technology that was built into the ARM reference architectures to do that, and they don't, called Trust Zone. It looks like they've actually done particular hardware, and they might link into Trust Zone. And researchers have told me they believe that the fingerprint sensor actually has an encrypted connection to the Secure Enclave. And so when you put your password in, this is my interpretation. Apple hasn't fully talked about this. My understanding is when you put your passcode in, that is stored in the Secure Enclave, but in memory only. That's why when you reboot the device, that's wiped off your device. And then your fingerprint, that will release that passcode and then kick it over to the main operating system to log you into your device. What does it mean? You always have to have a passcode on your device. Touch ID doesn't get rid of that. But now you can have a long passcode without having to type it in with your thumbs every time. It's great. It's awesome. Love it. Don't buy anything else if you can afford it. Because what Apple has done here through design is bring the strength of a long passcode to everybody with the convenience of just turning on your device. So that's awesome. Touch ID. And then mobile device management, I talked about the splits between the enterprise, what they can do, and then what you can do. Now I'm going to have to rush through this because I do like to end on time with these things and get into iCloud. So you can hit me up later if you have any questions. Oh, and real quick, the way I configure my device, if we can switch over to these. Switch to the phone, please. So the way I do mine in the settings, so aside from Touch ID, once you turn that on, that basically forces your passcode, and never use a simple passcode on these devices. The other things that I do that is Notification Center. I actually have that turned on, but you'll notice that, whoops, sorry, not Notification Center, Control Center. So that, if you flip up, you gain access to everything. I turn that off on my lock screen. For me, because if somebody can actually access the hardware on the device, that's a problem for me. Now, all that means is, because I have Touch ID, I open up my device, then I can access that immediately. So it's still just as convenient to turn on the flashlight or turn on and off wireless, those kinds of things. I do allow access from when I'm within apps on it. I actually allow my, what's this called again? Notification center. I actually do show this on my, so you have the option of disabling one and not the other. I show this on my lock screen because I don't care if someone sees my calendar for the day. They can't really affect anything. If they go to click on anything, so if I'm in a locked situation, turn it on. Yeah, swipe down, see, cute kids. If I go to a calendar appointment here, it's going to ask me for my passcode anyway. So I'm okay with that. So that's the core of the settings that I've got on there, plus I'll find my iPhone. It's really not much else that you actually need to do on iOS. And any questions about that before I very, very quickly go through iCloud? All right. And again, you can hit me up afterwards if you have specific questions. But from a technology perspective, it's awesome. The stuff they've done there is great, even well beyond what they've done with OS X. So the last pit is iCloud. The thing you need to know about iCloud, and they just a few weeks ago started talking about this publicly. Everything's encrypted. For the most part, it's encrypted with passcodes and passphrases that Apple can't access. What they've done, though, is it's graduated. So Apple has to, for example, there's no way that they cannot access your email. Because they have, if you think about it, if you log into a web interface in iCloud and you can see something, that means Apple has to have access to that data. So those things are encrypted with keys that Apple controls. But it's not like everything within iCloud is in one key. They actually use a bunch of keys. They use hardware security modules on the back end to store those keys safely and securely. So that's the rule of thumb. And this is not just for Apple, it's for anything. If you can see it in a web interface, you know that the provider on the back end has access to the keys to read it. They don't. They have a lot of internal controls, of course. But that's what they potentially can get to. And that's files and email predominantly. iMessage and FaceTime are encrypted end-to-end and in a very interesting way. If I do iMessage, they use actually a public-private key sharing mechanism so that we would, like Andrew in the front, we would exchange keys. Apple can't actually, they will distribute the keys to everybody's devices and it's part of an iMessage. And this happens instantly, pretty much. They will distribute the keys, but then once those keys are distributed, I'm encrypting my message with his public key, and he can only decrypt it with his private key. Now what's cool is if we were all in the room in one big iMessage chat room, we would all exchange keys, and when I send a message, it would encrypt it with each of your individual public keys. So we're not sharing a group key or anything. It encrypts them individually. It's very interesting. Now, Keychain Sync is pretty sensitive, and I never turned this on. So in Safari, you can say generate my passwords, save my passwords. I always use one password so I could have control. Because I'm like, well, I don't fully trust Apple. I don't know how Keychain Sync works, or Keychain Recovery. Well, it's pretty impressive. There's two different mechanisms. Keychain Sync is for syncing across all of your devices. There's a device enrollment mechanism, and then a key distribution mechanism. And basically what happens is if I have a password stored in my keychain, and by the way, your applications can decide to not store stuff in keychains if they want. But if I have a password stored in my keychain, that gets synced to all of my other devices one at a time. That is encrypted with keys individual to each device. That's part of my ring of trust, my circle of trust. It really is called the circle of trust for those seeing the movie. And in the crypto world. So there's the circle of trust. There's multiple encryption around it so each device can get that particular key. And the way it does the mechanism is Apple only has one key at a time passing through their servers. So there's not like a repository somebody could hack to get all of your keys. Most of iCloud, Apple stores everything and pushes it to your devices. iCloud Keychain Sync, it's a peer-to-peer arrangement where everything is synced device to device to device to device with only one key at a time running through memory with an Apple. Keychain Recovery is even different. Keychain Recovery, they do have to have your whole keychain if you want to give Apple access to that. There's a mechanism to protect that involving use of HSMs, which are it's the same hardware security, crypto hardware that banks use and retailers, and they work pretty well. It's a very well-established technology to protect your keys. Apple configured their HSMs to store stuff, then they literally broke the administrator cards, so they can't actually go back in and change their HSMs once one's configured. Why'd they do that? NSA proof, man. If they compromise an Apple employee, that Apple employee can only compromise things from that point forward. They can't actually go back and make changes to anything already stored within iCloud's data centers. Pretty cool. So they crack the keys, your stuff's pretty well protected, it'll pop your keychain out, be able to distribute it to the devices using a multiple encryption mechanism that's also tied to your iCloud credentials, as well as a iCloud keychain specific password. Now, the default's a 4-character password, don't use it. Okay, really easy to get around that. The second is you can put in a passphrase. If you use that, your code to recover your keychain, and the keychain itself is just in iCloud somewhere, but the keys is what's stored in the HSM. Your passphrase is what you would use to unlock that, and then notifications go out because there's all these mechanisms to make sure you get alerts on your device. But there's an interesting setting, and I wrote in a TidBITS article on this, which is if you have the option on your device that says, Apple, you generate a cryptographically sound passphrase for me, and Apple will give you it's a 16-character, I believe, maybe. Anyway, I'd have to double check that. And pretty random. And what that is that's generated with enough entropy in it so that Apple feels confident that they don't need to store your keys to actually do your keychain recovery on their servers. That means that the NSA can go buy Apple, and they can't get your keys if you choose that option to get your keychain. Because the only way to do it is to get that code off of your device. Now, if you want to set up a new device, you also need that code. So that's kind of one you want to write down. Sticky notes work really well. Maybe not on your monitor. Under the desk is totally cool. I don't care what they did in sneakers. No one will ever find it. No one thinks you'll do it anymore. I mean, you're covered. So I ran a little bit over on time here. The core of this is Apple's really thought this stuff through. Secure defaults, taking advantage of the latest hardware, putting a lot of effort in. Now, the operating system is always going to be vulnerable. Let's be honest. There are programmers like everybody else, and they're going to make mistakes. And there's open source components that are in iOS 10 and in OS 10 and in iOS. And there's, those things are going to have holes and flaws within them. So the goal is to make it harder for attackers to do anything bad, make it harder for attackers to even try to do anything bad through the default settings and stuff, and then make it economically unenticing for them to actually, because bad guys care about money now. It's not the days of just hacking for fun, for the most part. And by making it economically difficult for them to do anything bad to the overall Apple the overall Apple user base. You'll see headlines. You'll see hacks. But always remember in the back of your head, is this an isolated incident? Is this repeatable? And how widespread is this? And you read through all of that, you find out pretty much every time that stuff can't really go very far. That's why I don't use antivirus, for example. You just don't need it on our ecosystem. And the last is flaws exist, so don't be stupid. Make sure that you set these settings, because none of this works if you don't turn this stuff on. So thank you all for your time. And my apologies, I ran later than I even intended to, but there was a lot to cover.